Alright, this video is going to help us understand how to graph more quickly using what's called the vertex form. But to understand vertex form, we need to understand how our equation is set up first. If we think about a basic y equals equation, y equals x squared is about the most basic parabola or quadratic equation we can write. Vertex form is essentially a shifting of that equation. So if you remember how to shift equations, that'll make a lot of sense. But more than likely at this point, we really only dealt with quadratics in standard form. So let's show you how a vertex form, or what's written here, equation, can sort of be formed or help us understanding previously what a standard form equation did for us. So first of all, if we were in a form like this before, we always converted into standard form. So let's go ahead and do that again. Y equals 3 times x minus 5 squared, remember, is two sets of what we call factors of x minus 5 times each other minus 12. So we'll start off with doing a little bit of FOIL. If you don't remember how to do that, you may want to review how to FOIL. But again, that just stands for first, outside, inside, and last. So we're going to be doing a little bit of multiplying. X times x is x squared. Outside would be a minus 5x. Inside also a minus 5x. And the last being plus 25. Now, if you know the shortcut for that, you could probably jump right over that step and go right on to 3 times x squared, negative 10x, basically the first times the second times 2x times negative 5, doubled because of those inside-outside terms, and then the last term squared being our 25. Got a little bit more work to do as we need to distribute our 3 minus 30x plus 75, and then subtract our 12. So finally we are in standard form plus 70 minus 10 would be 65, minus another 2 is 63. We've got our standard form equation. Now remember, to find the x-coordinate of the vertex, we're going to grab our a value over here and our b value, and remember that x equals negative b over 2a will get us the x-coordinate of the vertex. So negative b will be 30 over 2 times a would be 6, and our x-coordinate of our vertex is going to be 5. Take that 5, plug it back in, and we'll just go right back up to our original equation. 5 minus 5 would come out to 0. So essentially you've got 3 times 0 squared minus 12. Well, 3 times 0 squared is just 0, which leaves you with negative 12. Now the big thing we want to recognize from there, and the reason we did all that work, is that if we looked exactly at our original equation, you might notice that 5 is just what's inside of our parentheses, and negative 12 is what's being subtracted on the outside. That goes to what vertex form really gets us. Remember that subtracting inside of our equation is a shift left or right. X minus 5 actually shifts us to the right 5 units. So instead of being at 0, 0, like we would have been for y equals x squared, we're 5 units to the right, or at x equals 5. Minus 12 is a vertical shift, or we're moving 12 units down, which is why our y value comes out to a negative 12. And that's really getting to what's called vertex form. If you want to quickly identify the vertex on a vertex form quadratic equation, you can really just look for what's being subtracted inside or added on the outside, because that h and k, those two numbers, will give us the vertex of our quadratic equation. We won't have to convert to standard form, and we'll deal with intercept form later. That's another form, but for right now we're just dealing with vertex form. So let's go ahead and try that without converting to standard form, how that can quickly help us make a fast graph of a quadratic equation, find that parabola very, very quickly. Notice down here in the lower left, I've got my y equals a. That's going to be our stretch vertically. We'll deal with that when we find more than just the vertex. But x minus 2 inside the parentheses squared plus 1, which just quickly tells me, again, according to my vertex formula, that my vertex will be at 2, 1, meaning that if I want to find more points, I just need to plug in points like 3 and 4 for x, or 1 and 0, and I can find other y coordinates. Now the downside is we do need to still plug those in and just find the y coordinates. So we can do that real quick. 0 minus 2 quantity squared plus 1. Well, 0 minus 2 is negative 2 squared is 4, times 2 is 8, plus 1 is 9. We can also go on and plug in, find all the rest of those points. So I'm going to pause the video very quickly and fill in those numbers. And then we'll also talk about how we can take advantage of our 1357 method to also help us there. All right, we've got our table filled in. Notice that we, again, had a vertex right in the middle. Then if you look very carefully, you'll notice that we went up 2 units, and then from there up another 6 units, which if you have watched the video and learned about the 1357 method would make sense. With that 2 out in front, once you plot your vertex, 2, 1, we're going to go up 2 units, or 1 times 2. Then we would go up 3 times 2 units, the 1357 method being doubled, so it becomes a 2, 6, 10 method. So 2, 6 more units puts us up at 9, and then we run out of room on our graph. Draw a quick parabola as smoothly as you can through your points, hopefully better than I drew there. And finally, if you want to put your axis of symmetry on, remember that's just going to run straight through our vertex at x equals 2. Remember to label your axes so we know we're counting by ones. And there's your vertex form parabola. Now, go ahead and try that again. With this example, I'm going to pause the video and fill in all the work. And we'll take a look and see that the 1357 method works as well for negative and fractional numbers. All right, hopefully you could find your y coordinates well. Again, from our equation, x plus 4 means that we went to the left 4 units. Left 4, which means we're at negative 4, and remember plus 2 means we went up 2 units, which means our vertex is now negative 4, 2. Plotted some x-coordinates around them, and then also notice that again with an a value at negative 1/2, it means from our vertex I'm going to travel down 1/2, then 3/2, then 5/2. So you'll notice that's where I went from my vertex, down 1/2, then down 3/2, then down 1, 2, 3, 4, 5/2, down to about negative 2.5 for the next one. Don't forget to label your axes, but other than that, it should be a fairly easy point to graph. Also, our axis of symmetry is at x equals negative 4. Remember, that's the x coordinate of your vertex. So if you can identify your h value, what that left shift was, you've also identified your axis of symmetry. Last thing to note is just how quickly you can use vertex form to help you in the real world. If you have a model that's already in vertex form, note the equation that we're given here for the path of a baseball thrown by a player forming a parabola. Baseball is going to fly up and through the air and basically form a nice parabola, starting off up a little bit off the ground, but then flying and hitting the ground. Well, what we want to know is if x is the horizontal distance and y is the vertical height, how high was the ball at its highest point? Well, remember the highest point is basically the vertex. So if we can identify the y coordinate of the vertex, the highest coordinate, we can find that point. And since we are adding 8.5 on the outside of our equation, I would say the highest we ever go is 8.5 feet. How far is the ball from the thrower when it again reaches the same height from which it was thrown? Well, let's go on our picture here. If this is the height from which it was thrown, and we go ahead and draw a line across there, what we want to know is, what's that x coordinate? How far from us at the beginning, from the thrower, is the ball if it's caught at that same height? Well, the beauty is if the vertex is on that axis of symmetry, and the vertex is 49 feet, according to our equation, away from the thrower, all we have to do is double that. So 2 times 49 would tell us that we are going to be 98 feet away when it again reaches the initial height that it started from. Now we don't know that height, we don't have to find that height. Again, all we wanted to know was how far is it from the thrower, how far is that horizontal distance. So there's your 98 feet. Hope that helps you out. Good luck with vertex form, and happy parabolas.